फटा हुआ है तू जैसे ऐसे बोल रहे ठीक है नहीं हाँ इसी में बोलेंगे हाँ नहीं अभी इसी में बोल ठीक है जब अलग अलग होगा तो तू माइक रख ले या फिर इसको दे तो ज़्यादा ठीक
Everyone are kindly requested to please take your seats. We will start in a short while.
आएंगे आज के बाद जनगण में स्टार्ट जनगण के लिए बोला हाँ बोले जनगण में दसा अरे यार क्या कैसे कर रहे सर तभी बुके दिया लेकिन डायरेक्टर से जब भी अपने मिनिमम होना होता है अच्छा ठीक है अगर प्लान नहीं है तो कुछ नहीं है
We can start.
A very good morning to one and all present here. I am Samadrita Basu.
And I am Ayan Datta.
And today we are gathered here on behalf of the Department of Earth and Atmospheric Sciences, NIT ROURKELA, for the auspicious inauguration of the National Conference on Land-Atmosphere Interactions, Controlling Weather and Climate, Applications of Numerical Models and Observations, LAI 2023. The Department of Earth and Atmospheric Science is set up to provide state-of-the-art education and research in earth, climate and ocean sciences. The department plays a vital role in providing resourceful manpower through interdisciplinary way of teaching and research programs.
Without further ado, we would like to welcome all our eminent speakers and guests from all over the country who have come here to share their knowledge and vast experiences with us. Now, we would like to invite our Honorable Chief Guest, Dr. Mrityunjay Mahapatra, to kindly come up on the stage and take a seat on the dais. Dr. Mrityunjay Mahapatra is the Director General of Meteorology in the India Meteorological Department since the year 2019. He was the Director of National Weather Forecasting Center, IMD, New Delhi from the year 2005 to 2010. Dr. Mahapatra is popularly known as the Cyclone Man of India. He is honored with the Honorary Doctor of Science from Odisha University of Agriculture and Technology in 2022, FM University Balasore and KIIT in 2023. He received Bharat Gaurav Award in 2019 and Achievers Award in 2013 for excellence in cyclone warning services to Cyclone Warning Division from India Meteorological Department and many more.
Now, we would like to invite our guest of honor, Dr. Chandan Kumar Shahu, to kindly take a seat on the dais. Dr. Chandan Kumar Shahu is the Dean of Faculty Welfare of NIT ROURKELA. He is currently the Professor of School of Management, He was the head of the Department of School of Management in NIT ROURKELA from the year 2013 to 2016. He was also the chairperson and PGDM coordinator, HDF School of Management, Naranpur, Cuttack from 2008 to 2009. He is also a life member of Indian Industrial Relations, IIRA, New Delhi, Indian Society for Training and Development, ISTD, New Delhi.
Now, we would like to invite our Honorable Director, Dr. K. Umameshwar Rao, to kindly take a seat on the dais.
He's not here. Change the name.
Sorry for the interruption. Actually, director sir's wife is unwell, so today's in charge director is Professor Pradeep Sarkar. He is the Dean PD of NIT ROURKELA. So let us welcome him with applause.
Now we would like to invite the head of the Department of Earth and Atmospheric Sciences, Dr. Jagabandhu Panda, to kindly take a seat on the dais. Now I would like to request Shubham to kindly come up on stage and honor our HOD.
Now, we would like to invite the convener of the conference, LAI 2023, Dr. Krishna Kishore Osuri, to kindly take a seat on the dais.
What about Sandipan? What about Sandipan? Sandipan Mukherjee. Okay.
Now we would like to invite Dr. Sandipan Mukherjee to take a seat on the dais. Dr. Sandipan Mukherjee joined as a scientist in Govind Ballam Pant National Institute of Himalayan Environment and Sustainable Development since 2013. He joined as a teaching fellow and later became a senior teaching fellow in University of Canterbury, New Zealand in 2012. His area of specialization includes climate change, hydrometeorology and monsoon climatology and dynamics. He is a life member of Indian Science Congress and Indian Meteorological Society. He also received an early Career Research Award, Government of India, in the year 2019. Now I would like to request Dushyant to kindly come up on stage and honor Dr. Sandipan Mukherjee.
Now, we would like to call upon the stage Dr. Krishna Kishore Osuri to address the gathering and speak a few words about the conference.
Thank you very much, and a very good morning to everyone. And it is my pleasure to invite or welcome you all to the national conference, Land Atmosphere Interactions Controlling Weather and Climate Applications of Numerical Models and Observations. And actually, this conference is mainly in the support of our ongoing network proposal, supported by GB Pant Institute and Ministry of Environment, Forest and Climate Change, and partly supported by Indian Institute of Geomagnetism, Mumbai. And as we know, the theme is land atmosphere interactions and controlling weather and climate. And we all of us know the importance of land atmosphere interactions. So with this, I would like to thank chief guest and Dr. Mohapatra. And if I want to say, like, he is my mentor from the beginning of my career. Actually, he is my mentor. So I would like to thank him here. And another guest of honors, like a few guest of honors are unable to join us because of their sudden occupancy. And we are like, here we can see a good gathering, about 70 participants are there, and I hope the conference will provide sufficient knowledge and experience to share with everyone. So I encourage all the attendees to make the most of their time and the conference by networking with each other and sharing the ideas. So I want to take the moment to thank my colleagues in the Department of Earth and Atmospheric Science, NIT ROURKELA, and their hard work and dedication in organizing the conference. And thank you very much.
Thank you, sir. Now, we would like to call upon the stage Dr. Jagabandhu Panda to address the gathering and speak a few words on behalf of our Department of Earth and Atmospheric Sciences.
Good morning, one and all. So hopefully this evening has been good for everyone, although it's not good to see that the director sir is not physically available because of his wife's health conditions. However, I am happy that at least our director in charge, Dr. Professor Pradeep Sarkar, is available for us, irrespective of his own personal assignments. So, respectfully, I would like to begin with the dignitaries in the dais. Our Honorable Director General of Meteorology, Dr. Mrityunjay Mahapatra, Dean Faculty Welfare, Professor Chandan Sahu, and other participants available here, my media colleagues and my fellow colleagues, Dr. Rohan Dhiman, the Registrar of NIT ROURKELA. So, good morning again. I would like to express my happiness to see a significant number of participants in the conference that the department has organized for the first time in such a scale. For this, I would like to congratulate Professor Krishna Kishore and appreciate his efforts to get the required funding from various sources and also trying to manage with the limited resources available. In a decade-long history of the department, arranging a conference of such a scale has been possible mostly because of his efforts. Others, including me, are only helping to make it success. I hope the next 3 days would be a great experience for all of us. I had a dream basically to organize a conference at a bigger scale. However, I don't know if it will be possible in future to materialize by getting all the supports from every sphere possible. However, maybe if in future, if it is possible, maybe we can manage to have a conference like TropMet. Like last time I went to IJR Bhopal, where multiple parallel sessions were being organized, and some of the participants who are available here met us there as well. And maybe if we have some facilities in future like that, we'll arrange a bigger conference and hope to see some of you in that also. Now, I would like to highlight that our department is completing 10 years in 23 itself. So it started in 2013 conceptually, and in 2014 practically, when myself, Professor Bhaskar Kundu, and one of the visiting faculties, Professor H.K. Mishra, who later joined IIT Bhubaneswar and is serving there as an adjunct professor now, joined, and also Professor Ikunidin, who was part of the mining department, was transferred to our department. Now we are actually 9 faculty colleagues, faculty members in total, where basically there are 4 faculties in earth science and 5 faculties in atmospheric science. We started with MSc Applied Geology course in 2014, where 10 students joined the program. And now we have 3 postgraduate courses, that is MSc Applied Geology, MSc Atmospheric Science, MTech Atmosphere and Ocean Science, where basically we have 80 students per batch who can join in each year. That means we can host 160 students altogether. Besides, now we are hosting basically 30 PhD scholars at present. We work on 20 to 25 research areas, and till now published nearly 300 research articles. In 2022 itself, we published about 70 articles, and because of the good research works, our faculty colleagues and students have received Best Paper Publication Awards, Young Scientist or Researcher Awards from various scientific societies, panels, or ministries. One of the notable facts I have to highlight that recent past, Professor Bhaskar Kundu received Young Researcher National Award in 2022 from Ministry of Earth Sciences for his contribution in the field of geosciences. He is available here. Till now, the department has awarded 14 PhDs, 4 have submitted or about to defend their thesis, and our PhDs have either joined some jobs or postdoc positions in India and abroad. All of them are engaged or employed. Only even the students who have submitted the thesis also are getting jobs. And about 75% of our MSc and MTech students or graduates have got jobs through on-campus or off-campus placements, or joined other organizations of national and international repute for further studies. I would like to highlight that 2 of our graduates could get Institute Gold Medals during these 10 years of department's existence. One of them would be receiving the gold medal in the forthcoming convocation. A department brochure and a newsletter have been actually prepared to highlight various aspects relating to academia, research, placements, etc. for your information. You can see these things. And all the conference participants must have got the same. Those documents would further enlighten you regarding the Department of Earth and Atmospheric Sciences, NIT ROURKELA. One aspect that I want to highlight that we have planned to sign 3 MOUs with 3 different organizations of this country to enhance the research base and expand the academic and research collaborations. And today we are going to sign 1 MOU with IMD for establishing a multi-parameter meteorological observatory and installation of AWS, besides academic and research collaboration and cooperation. IMD has already provided AWS, and the same is already installed and functional except its pressure sensor, which is being taken care. Subsequently, we expect that IMD will provide other instruments for complete and full-fledged ground observatory. Honorable DGM Dr. Mahapatra sir is present here to sign the MOU and inaugurate the observatory complex today. We are glad to host him today and thankful to him for considering our request for this purpose. With all these aspects I have shared with you all, I would like to say that the department would continue to thrive and contribute to the society through the quality research and academic activities. Thank you. With this, I would like to take your leave and not take so much of time. Thank you for your patience, and I hope you will enjoy the conference inaugural function. Thank you.
Thank you, sir. Light is a symbol of brightness and prosperity as it expels the darkness and brings blessings, prosperity, and happiness in our life. To make this morning a blessed one, we would like to invite our honorable guests for the lighting of lamps.
Thank you, everyone. Now I would like to call upon the stage the Director in charge of NIT ROURKELA, Dr. Pradeep Shorkar, to address the gathering and say a few words.
Esteemed Chief Guest, Dr. Mrityunjay Mahapatra from IMD, Dr. Sandipan from Indian Institute of Geophysics, my colleague Dr. Chandan Sahu, Dr. Jagabandhu Panda, Dr. Osuri, and Dr. Rohan Dhiman, participants, students, and delegates, a very good morning to all of you. I welcome all of you to the inaugural program of the National Conference on Large Atmosphere Interaction Controlling Weather and Climate, Applications of Numerical Models and Observations. And this is also, as the this backdrop presents, that is, it is a part of the Azadi Ka Amrit Mahotsav. So our country got the freedom in 1947, 75 years back. And soon after that, we have given a lot of time and effort in science and engineering to build infrastructures and resources. But then, in building infrastructures and resources, we have somehow impacted the climate in a big way. So after the 75 years, now I see this earth and atmospheric science and this climates, they are going to be the very, very important area of research and development and discussions for the entire globe, but it is especially for our own country. And I am very proud that NIT ROURKELA has included this very, very important department in our family. And it is, as our Professor Jagabandhu Panda told, that it is only a 10 years old department, but from my experience in last 10 years, that it is not although it is a younger department of our institute, but it is one of the strongest department in the institute, with the help of the very qualified faculty members, bright students, and their activities that proves that they are one very important department. And I am very proud of this department, and I hope that this future of NIT ROURKELA will be in a great way, will be on the shoulder of this particular department. With this background, and I am very sure that the able people of this department will make a very, very interesting sessions in this conference, which will impact the knowledge and understanding of all the participants. I wish this conference a great success. Thank you very much.
Thank you, sir. Now, I'd like to call upon the stage our guest of honor, Dr. Chandan Kumar Sahu, to address the gathering and enlighten us with a few words.
Good morning to all. Honorable Chairperson of this event, Director in charge, Professor Sarkar, the Chief Guest, Professor Dr. Mrutyunjay Mahapatra, Director General, IMD, and another dignitary, guest of honor, Kishore, Sandipan Mukherjee, and HOD, Professor Panda, and the Convener, Registrar, Professor Dhiman, professors, my colleagues, officers, dear delegates, students, media friends. So it is an opportunity, though I am old man, I have no knowledge about atmosphere and whatever, but this is a great occasion, and we are having the great personality of India and son of the soil, nothing but Odissas, and this time we are to be very much proudful. We are having with Dr. Mahapatra, and who is having vast of knowledge. Though we have observed, we have seen, while any cyclone, basically the man, cyclone man, and we have continuously watching his words, but the reality we are seeing, thanks to the department, and we are having such a experienced and we say expertise, so that definitely our faculty colleagues, they will get benefit out of that. So when you think about the topic land-atmosphere interaction and how it controls weather and climate, based on that, and they will develop or find out the application or numerical models, nothing but the predicting behavior or models. So predicting and estimation. So how they can quantify based on land-atmosphere interaction, how climate change is there. The current position is what, how we can think of, have to save our earth and we have to save our planet. So this is the high time the Department of Earth and Atmospheric Science has arranged and organized a burning point of thought or discussion from 9 to 12. So during these 4 days, and our participants or delegates, and they have to present their different thoughts. We have to see, find out the problems or new inputs. Again, we can carry and we have to research, or again, we can accelerate our research. So the outcome of this event may be a great success. I wish all the best. Thank you. Thank you all.
Thank you, sir. Now, I would like to call upon the stage our chief guest, Dr. Mrityunjay Mahapatra, to address the gathering and enlighten us with a few words.
Namaskar, good morning to all of you. Dear Professor Pradeep Sarkar, Director in Charge, NIT ROURKELA, Professor Chandan Kumar Sahu, Dean Faculty Welfare, Dr. Sandipan Mukherjee, Indian Institute of Geomagnetism, Dr. Rohan Dhiman, Registrar, NIT ROURKELA, Professor Jagabandhu Panda, Head of the Department, Dr. Osuri Krishna, distinguished faculties, students, press and electronic media, ladies and gentlemen. At the outset, I congratulate NIT ROURKELA for organizing this national conference on this very important theme, that is land atmosphere interaction controlling weather and climate, applications of numerical models and observations. I congratulate the department for completing the successful journey of 10 years. As Professor Sarkar was mentioning, within these 10 years, there has been significant achievements by the department in the field of earth and atmospheric sciences. It has been possible because of the ambient environment available for carrying out the academic and R&D activities in this region. So therefore, my congratulations goes to not only the current faculties at the administration of NIT ROURKELA, but also the former students, management board, authorities, and professors involved from the very beginning to realize this goal of 10 years. I was just going through the various activities and the vision of this department. It is worth mentioning that even though it is too young, but it has a high dream, a vision which can be possible to realize with the strategy adopted by the department. As far as the topic is concerned, yes, it is very contemporary, and it is the need of the hour. As all of us know that the weather or the climate has no boundary. It is a continuous process. And I always tell that whatever weather phenomena we realize, that is the byproduct of various interactions among the various spheres. Be it the lithosphere, where the scientists are working here, professors are working here on earth sciences, or be it the hydrosphere, including the water and cryosphere, or be it the atmosphere, biosphere. All these spheres are interacting with each other. So as a result, whatever we see today, cold wave, or sometimes the heat waves, or sometimes the thunderstorms, tornadoes, or the cyclones, depressions, or low pressure areas, or monsoons, these are all out of those interactions. From the very beginning, if you look at the ancient era, people have tried to understand the various aspects of these interactions. People have tried to understand the cause and impact relationship of the various weather phenomena. And perhaps, therefore, the simple proverb goes in everybody's mind that morning shows the day. And when we get up from the bed, we look at the sky and try to give a forecast for today. If it is sunshine, then we say that today weather will be good. If it is cloudy, we assume that weather will be cloudy throughout the day. If it is raining, we feel that it will be raining throughout the day. So that is the way in which the ancient human beings started to predict weather, started to monitor the weather. But that is not the case. Even if you have some weather in the morning, in the evening it may be different. So therefore, people tried gradually to understand the various aspects of the variations of weather, how it is impacting our day-to-day life. If you go to our ancient era in Rig Veda, you can find out the importance of measuring the rainfall. If you come to Yajurveda, you will find out the measurement processes for rainfall. Similarly, if you go to any Vedas and Upanishads, you can find out the description about the need of monitoring the weather and also the process for monitoring the weather. In Brihad Samhita, when it came off 800 AD before, it was mentioned that Adityat Jayate Brishti. That means sun creates rain. And if you analyze this statement, sun creates rain, what we understand now, that is the water cycle. So therefore, the water cycle has been understood at that time, and people have tried to define the role of sun, role of earth, and the atmosphere. And gradually, when you come up towards medieval India, you will find that great Chanakya has tried to measure rain, and he has discussed about the importance of rainfall measurement for the economy of the country. And finally, he also devised a rain gauge. And the rain gauge devised by Chanakya is cylindrical in nature. It was measuring just depth of water. So you just imagine, now if you just look at any rain gauge which has been installed near, that is in recent past, you have the rain gauge here also. What you find actually, it is just a cylinder with a funnel and with some certain characteristics so that there is no runoff, no evaporation, no radiations, nothing like that. The system has improved over the years with quality, but however, the basic concept of measuring rainfall still stands, that the pot should be cylindrical. So therefore, you can just imagine how the people tried to understand at the time, and they have come up with the devices for measuring rainfall. In the modern era, if you just look at, again, Greek Aristotle came up with the book Meteorological, which defined about the various aspects of weather measurements and its informations. With the advent of Galileo, the thermometer, and the instrumental age of meteorology started, and gradually we came off with monitoring the observations. So there was a continuity throughout, and that monitoring led to the accumulation of wealth of information over the years, and people tried to utilize it. And then came the beginning of synoptic meteorology. Synoptic means the simultaneous. The simultaneous measurement of observations throughout the globe was taken off with an understanding that we cannot take a picture of the earth. At that time, there was no such camera which can take the picture of the entire earth. But people could understand that if you can take the observations globally at a fixed time, then you can utilize this information to find out what is happening now. And that information can be utilized to predict for the next few hours. So that is the concept of the synoptic meteorology. The simultaneous observations are taken at the fixed time of GMTs, like 0, 3, 6, 9, 12, 15, 18, 21. Then gradually, when the observations went in again, there was accumulated information. People tried to understand the various weather systems, like low pressures, high pressures, etc. And hence, they tried to develop the climatology of various weather systems. And hence, the people utilize the climatology, that is the statistics of the past weather, with the concept of analogy to predict the weather in future in association with a particular weather systems. So that is method of synoptic climatology. While all these were going on, people could understand that atmosphere is not stationary. Atmosphere does not have a memory. Statistics can run only with the memory. And memory does not last long. Even if you ask what I or we have eaten in the morning, perhaps all of us cannot speak correctly what we have eaten in the morning. And when you consider the past history to develop the statistical tools and to predict for a longer period, certainly there will be limitations in statistics. So therefore, statistical processes which was adopted then based on the past data had the limitations. And people thought to accumulate the information through the dynamics of the atmosphere, ocean, and earth. And that is the beginning of the dynamic meteorology in 1900, beginning of 1900, especially in 1930. We came up with a dynamical modeling system where people tried to develop some kind of single column model, assuming that the column is independent. There was a large error in the forecast. Then people thought that, no, we cannot concentrate only in one column. We have to consider the two-dimensional. Then they took the observation in 2 dimensions. Again, it failed. Then the people came up with the 3 dimensions. Again, also it failed. But however, gradually the error decreased. And now the people deal with the 4 dimensions. The observations are taken in 4 dimensions. The equations are defined in 4 dimensions. And with these equations, with the help of the development in computing quality, we have the high-performance computing system to solve those equations, which are nonlinear in nature, and hence to provide the forecast. So this type of forecast, which is called as dynamic meteorological forecast, that is once is called as the numerical weather predictions. So these are called numerical weather prediction models because these are the nonlinear equations which cannot be solved by the linear processes. That means I want to say that in the meteorology, 2 plus 2 may not be 4. So for example, if you are traveling in a curved path of 2 kilometers, another curved path of 2 kilometers, so the point of beginning and point ending your journey, if you calculate the straight distance, it will not be 2 plus 2. So that is the phenomena which occurs in the atmosphere or ocean, and therefore all this nonlinearity creeps into the process of calculations, and therefore you do not end up with 4. So therefore, what to do then? So simultaneously, there was development in other branches of science. We came up with numerical mathematics. So according to numerical mathematics, you can fit into with polynomials into the differential equations. And higher the order of the polynomial, more is the approximations, and hence the less is the error. So if we will try to fit the polynomials to the nonlinear differential equations, and hence to solve it, and going on increasing the number of order of the polynomials means you have to compute more. Therefore, you need the high-performance computing systems. The other way we try to solve the numerical equations with the help of the various schemes by equal spacing, just like y is equal to fx, delta x approaches 0, or delta x limits to 0. So that concept came to the gridded methods. First we came up with the finite distance methods, then finite element methods, and now people are coming with the finite volume methods in 3 dimensions. So there are 2 frameworks of the modeling systems, and you will be happy to know that India Meteorological Department and Ministry of Earth Sciences have both the frameworks, that is gridded framework and also the spectral framework based on the polynomials fitted to the equations. So while doing all these things, people also thought that you cannot have the solutions for predicting a few hours and predicting a month, or predicting a season, or predicting a few days. There should be some kind of unified approach to solve these mathematical equations and the various processes working in the atmosphere. So that came the unified theory, and now people are talking about worldwide for unified approach for all scales of space and all scales of time to solve these mathematical equations and find out the solutions. So you might be wondering that, is it that the equations which are solved, that is final, whether forecast can be provided by those equations only? No, because as I told you, all these solutions which are coming up, even if with infinite number of terms in the polynomials, still have the error due to various reasons. One of the reasons is that this numerical modeling, when you go for this concept, basically believes that it is an initial value problem. Initial value problem means if you can characterize the initial status of ocean, atmosphere, and earth, then perhaps you can give a better forecast, because you are extending the time scale from 0 to infinity. So therefore, the need is that you should integrate more and more informations through observations in all dimensions, that means space and time, and also from all the spheres, because these spheres are not independent of each other. So by that way, the process goes on to improve the initial status. So therefore, the model which have the better initial status with more integration of the data can be assumed to provide the better forecast. So that therefore process continues. So every national meteorological and hydrological agency try to accumulate more information through better observations. The observational network goes on improving in terms of quality and also in terms of quantity. And these observation networks are not simply the manned observations, but the automated observations in the surface, but also supported by the observations from the sophisticated tools like satellites and radars, geostationary satellites, polar orbiting satellites, and of course the Doppler radars and many other instrumental tools. So after doing all these observations, then the point is that whether we are able to represent all the physical, chemical, biological processes in the atmosphere in our models. So if we will try to parameterize the various types of processes. So understanding of physical processes, people will carry out the experiments within laboratory and outside and find out the new parameters representing the various processes, starting with the small cloud scale to the large scale weather systems like monsoon or the trade winds or the tropical easterly jets or subtropical westerly jets and many more. So once you do that, and then the point comes whether you have got sufficient computing power to resolve all these informations and process all these informations. Therefore, people go on increasing. So there was a time when we did not have the computer. In 1990s, we came up with the first supercomputer. Then now we've got a fourth supercomputer in the country with Mihir and Pratyush in Ministry of Earth Sciences, which is utilized to run 7 numerical models every day, morning and evening. And the capacity of this model was that it has the 10 petaflop, that is 10 into 10 to the power 15 floating point operations per second. So with this capacity, when we take observations at 5:30, we can have the forecast for next 10 days by 9:30. So all these forecasts are generated by all these models. Now once the forecasts are generated, as you know that computer generates only the digital values. These are not the values which are communicated to various disaster managers, general public, and stakeholders. So there is a need for post-processing of the data generated by the numerical models solutions. And that solution are of two types. One is that, first is that there are errors which cannot be utilized directly for the forecast, and hence it needs a dynamical and statistical downscaling so that error can be minimized from the output of the numerical models. And second one is that the output of the model may not be as required by ROURKELA or by Bhubaneswar or by Ranchi. So therefore, it has to be tuned towards the requirement of the specific stations or specific districts or specific regions. So by that way, people try to downscale the information available from the numerical models as per the requirement. Not only that, there are different requirements by various stakeholders. The requirement of defense forces is not same as the requirement of the farmers, the requirement of the fishermen, or requirement of an industry. So therefore, the stakeholder-specific, user-specific informations are also generated, which is called as public weather services. And you'll be happy to know that over the period of time, just like in the leading countries, India has come up with the augmentation of weather and climate services with improved forecast accuracy. And there is still scope now to improve the weather forecast also. At the same time, also, there has been development of the climatic information for climatological applications for long-term planning. And taking advantage of this information, improved information, IMD has introduced the impact-based forecast. That means you can not only provide what the weather will be tomorrow for ROURKELA, but you can say what the impact will be, what the weather will do in ROURKELA. If I'm predicting that there will be say for example, heavy rain over ROURKELA, I should tell whether that heavy rain will lead to inundation in a railway station or inundations in Vasandi colony or inundation in a particular slum or bus stand, so that the authority can take action to minimize the losses and hence save the lives and properties. So this impact-based forecast is being provided now for all types of severe weather in the country. But while going for impact-based forecast, you need the various other informations. It's not simply the weather information, but also you need the information about the hazards, you need the information about the vulnerability, you need the information about the risk assessment. So basically there are 4 components. One is that meteorological information you need, and particular meteorological hazard can lead to the secondary hazard or tertiary hazard. For example, if there is a flood, it can be health hazard afterwards. There could be inundations. If it is cyclone, there can be wind hazards, there can be rainfall hazards, there could be storm surge hazards, and there could be the various hazards, secondary and tertiary. So therefore, there should be primary hazard digital values supported by the secondary and tertiary hazards in digital informations. And third one is the geospatial platform. You should have a geospatial platform, digital platform with high resolutions, so that the city of ROURKELA can be represented in terms of its topography. And fourth one, what you need is the socio-economic conditions. The socio-economic conditions has to be digital. That means if you want to predict the inundation in ROURKELA because of the heavy rain, you should know the slum structure. You should know the location of the slums, location of bus stand, location of railway station, location of hospitals, location of shelters. So all these locations should be digital. So therefore, this, if you can have all these information in digital format, that can be superimposed to each other, and hence you can have the assessment of the hazards, assessment of the vulnerability, and hence assessment of the risk. So that is the need of the hour at present, and IMD is working with state government and many other agencies, and also the various academic and R&D institutes. So there is enough scope, therefore. It is not simply in the numerical weather prediction modeling, but also in hazard modeling. All weather will not be hazardous, and there will be certain weather which would be more hazardous or less hazardous. So I am happy that there has been significant improvement, and considering the state of Odisha specifically, there has been significant improvement with respect to IMD's interventions to improve our observational network, prediction systems, and early warning. And perhaps you will be knowing that in view of the World Cup hockey, we have got the observation systems installed in ROURKELA, one in the ROURKELA airport, another in NIT ROURKELA. All these informations are being provided to the authorities for the smooth conduct of this program. So I congratulate this department for taking initiative for establishing this observatory also. I am sure that it will help the students in academics and faculties to understand the local weather and also to utilize it for their practical purposes. At the same time, it will also help to continue some kind of R&D. But I want to say that it is not limited only to this department's observatory, but you can work with any type of data which is available from India Meteorology Department. After my taking over, we have considered an open data policy. Whatever data is needed for research, it is available. We have come up with a climate data portal. You can utilize all this data and carry out your research either independently or in collaboration with India Meteorology Department and Ministry of Earth Sciences. What we need actually, collaboration is key to success. I believe in that. If all of us collaborate with each other, academically and R&D-wise, certainly we can do the marvels. We can improve the understanding, we can improve the monitoring and prediction systems, and hence the service to the society. I want to mention here that this is such a science, the science of meteorology, which is directly involved to the society. People talk about science to society, you can see that it is directly. If you do a small thing, you will find that there is a huge support or huge gain for the society. The society has gained a lot in terms of the minimizing loss of lives and properties. Society has gained a lot by utilizing weather and climate informations to enhance the economic conditions. I'll just take one example. If you consider the agro-meteorological services, weather services for agriculture, you will find that, let us consider BPL family, a family which is lying in below poverty line, a family who do not have large-scale farming, a family who do not have the capacity for irrigations. And we have seen by the independent survey that if that family utilizes weather informations, they gain about 12,000 rupees per year. If they do not utilize, they lose 12,000 rupees. The information can be utilized in crop scheduling, information can be utilized for farming, and information can be utilized to minimize the losses at the time of harvesting. So like that, if you consider the power sector also, there is a huge gain. I'll just take one example. When cyclone crossed Hudhud, Visakhapatnam steel plant, it could, and Visakhapatnam, they could manage, and power structure can be managed so that they could save 500 crore rupees because of utilization of information about the cyclones. So like that, if you just consider the cost of evacuation, that is reduced by about 500 crores in any cyclone, because evacuation is huge cost. Now, because of the improvement in accuracy of the cyclone forecast, also that has been possible. So like that, you take any sector, there has been a huge gain. But still, there is scope. And as all of us know that 5% of GDP is lost because of the disasters. So therefore, if you can improve at least 5% of GDP, there will be huge gain in the economy of the country. Certainly, we have done something with respect to cyclones, heat waves, and heavy rains, etc. But there is still scope, especially with respect to the lightning. And this region especially is very prone for the lightning activity. There is North Odisha, Ganjari West Bengal, Jharkhand, this area. This is called as Northwestern area. And many people die. Every year, almost 2,500 people die in the country because of lightning. And we have come up with the forecast for lightning. But there is still scope to improve the understanding of lightning and provide the forecast in time and outreach. So what I urge upon that the institute here can work not only on the academic, but also in the outreach programs to explain to the people, to make awareness campaign, and also to help the society to minimize losses in lives. So thank you very much. I will stop here. I wish NIT ROURKELA and Department of Earth and Atmospheric Sciences will flourish in the years to come, as it has done in the last 10 years. It will go on leaps and bounds and will create a new history in the coming years. And also, the particular national conference will be a success for all the faculties, students, and researchers participating in this program. Thank you very much.
Now, I would like to call upon the stage our chief guest, Dr. Mrityunjay Mahapatra, and our director, Dr. Pradeep Shankar, to launch the abstract volume.
Now, I would like to request the Director in charge of NIT ROURKELA, Dr. Pradeep Sarkar, and the Director General of Meteorology, Dr. Mrityunjay Mahapatra, for the MOU signing between the Department of Earth and Atmospheric Sciences, NIT ROURKELA, and India Meteorological Department. Now, I would like to request Dr. Pradeep Sarkar to give the memento to Dr. Mrityunjay Mahapatra. Now, I would like to request Professor Krishna Kishore Osuri to give the memento to Professor Chandan Kumar Sahu. Now, I would like to request Professor Krishna Kishore Osuri to give the memento to Dr. Sandipan Mukherjee.
Jagabandhu Panda, sir.
Sorry for the inconvenience. I'd like to request Professor Jagabandhu Panda to give the memento to Dr. Sandipan Mukherjee. Now, I would like to request Professor Krishna Kishore Osuri to give the memento to Professor Pradeep Sarkar.
Now, we would like to call upon the stage Dr. Sandipan Mukherjee to address the gathering and give the vote of thanks.
Good morning and namaskar to all. I deem it a great honor to propose vote of thanks on this very occasion of inaugural session of LAI 2023. Let me begin with expressing our gratitude to the Almighty for blessing this occasion as a success. First and foremost, I thank Chief Guest of this conference, Dr. Mrityunjay Mahapatra, Director General, India Meteorological Department, Government of India, for gracing this program. Thank you for your time and blessing, sir. We are grateful to Professor Chandan Kumar Sahu, Dean of IIT Bhubaneswar, guest of honor for this program, for his kind and encouraging words. The program could have not been completed by the nice hosting of NIT ROURKELA without the active support of Director Sir and Director in charge Sir, Professor Sarkar. Thank you very much for allowing us to organize this program, sir. The program was positively organized and implemented by Dr. Jagabandhu Panda, HOD of the Earth and Atmospheric Sciences, NIT ROURKELA, and Dr. K.K. Osuri of Earth and Atmospheric Sciences, NIT ROURKELA. I would further elaborate that although many of us are part of this conference, but Dr. Osuri's effort to smoothly organize this event needs a special attention. I also express my thanks to Professor A.P. Dimri, Director of IIG, Professor Sumit Sen from IIT Roorkee, Professor Sumibal Ghosh from IIT Bombay for their insight and support to organize this program. This event was conceptualized under a collaborative research between IIT Roorkee, IIT Bombay, NIT Rourkela, and G.B. Pant National Institute of Himalayan Environment under a project program of National Mission on Himalayan Studies. So I also express my thanks to the financial support from National Mission on Himalayan Studies, Ministry of Environment, Forest and Climate Change, Government of India, and Indian Institute of Geomagnetism, Mumbai. I also thank the director of G.B. Pant National Institute of Himalayan Environment from Almora, Professor Sunil Nautiyal, and the nodal officer of NMHS, Engineer Kirit Kumar, for supporting this program and allowing us to collaboratively organize the project as well as the program. My thanks to all the dignitaries, invited speakers, and contributors participating in this project, including media persons. And finally, my thanks to all the technicians and students and IT experts who have helped us to organize this program smoothly, and hopefully we'll be organizing the program smoothly in the coming 2 to 3 days. In case I forget to thank any other particular person involved in this program, I apologize and wish this occasion a great success. Thank you. Thank you very much, sir.
Now, as we have come to the end of our program, we would cordially like to invite all our eminent guests for the high tea outside the auditorium. Thank you everyone for coming here.